Investigation of Curves, Section 1, Equations and Properties of Curves. Video 6, Converting from Polar to Parametric. This is the second of our 3 videos about converting between one form and another, because sometimes it's much more convenient to do one thing in one form and another thing in another form. So let's imagine that we had some polar coordinates and we wanted to express the curve using parametric equations instead. Well, what we can do is we can simply use the fact that we've got r cos theta is x and r sin theta is y, and then we can replace theta with t, and then we're going to have something which expresses x in terms of t and y in terms of t. So we've got a set of parametric equations. Let's work through an example of this. Express r equals cos theta plus k as parametric equations. Well, first of all, I know that x is r cos theta, and I know that y is r sin theta. I'm going to substitute for r. So that means that x becomes, well, r is cos theta plus k, and then r cos theta, so cos theta like that. Y is r sin theta, so it's cos theta plus k sin theta. And then I'm going to replace theta with t. So I've got x equals cos t plus k times cos t, and y equals cos t plus k times sin t, like that. Let's look at that neatly. So I started by writing out x and y in terms of r cos theta and r sin theta. I substituted for r, so I've got x equals cos theta plus k cos theta and cos theta plus k sin theta. And finally, I replaced theta with t everywhere, so I've got everything in terms of a parameter t. Now, you might find this last step a little bit strange and wonder why we don't just keep it as a parameter of theta. This is more important really when you're going back the other way. There's a danger when working with parametric equations that if you have something which is called theta as your parameter, you'll think of it as being something that goes from 0 to 2 pi. And sometimes your parameter t does go from 0 to 2 pi, but not always. And so if you get into the habit of always using t as the parameter for your parametric equations and thinking carefully about what values that parameter t can take, you're less likely to fall into the trap of thinking that you've got limits on t that aren't there. So that's why it's a good habit to get into, to replace theta with t so that you're absolutely clear we're working in terms of parametric equations now. In this video, you've learned how to convert from polar to parametric form.